Bismillahirrahmanirrahim. First of all, I want to present myself. I am Benmansour Jalal Eddine, researcher fellow from Satellite Development Center. In this presentation, I'm going to talk about mathematical modeling of attitude flexible satellites and their main disturbance. Okay, our work are outlined as follows. First, I will give an introduction. Next, I am going to provide the satellite's attitude dynamics. Last, I will present the different model disturbances. Finally, I will conclude my presentation. All of communication satellites are considered as flexible satellites. For this reason, it is important to study this kind of spacecraft where are visible from large area of the Earth's surface, and it can be seen everywhere in our life, such as television, telephone, internet, etc. Before talking about satellite dynamics, it is important to know the three-angle rotation of our systems. The first is the angle phi, which represents the rotation around x-axis. The second is theta, represents the rotation of y-axis. And the last is the psi angle, which represents the rotation of z-axis. Okay, the dynamic equations of motion of a satellite can be derived from the Coriolis theorem. The equation describes the relation between the internal torque and the external torque acting on the spacecraft, where the second differential equation describes the motion of the satellite. I is the moment of inertial tensor in body coordinates. H is the angular momentum of reaction waves. Omega is the satellite angular rate vectors. T int is the internal disturbances, and Tx is the external disturbance, and U is the control torque. The Euler parameters in terms of angular phi and the axis of rotation E are given by the four first equations, where Q is the attitude quaternion vector, E is the Euler vector in the orbital frame. The four Euler symmetric parameters are not independent but satisfy the following property, where the sum square of them is equal to 1, and finally the rotation matrix is expressed in terms of the symmetric Euler parameters expressed in matrix A. Concerning the disturbances acting on the attitude of our satellites, the radiation solar are as external disturbance is considered as external disturbance, and the main one is focused in this study is the internal disturbance, which include the flexible appendages, fuel loss in the tank. Mathematical model of the flexible vibration is given as follows, where the tau is the torque of the wheels, L stars is the Lagrangian, theta is the rotation angle of the satellite around the axis, m is the dissipation energy associated with the deformation of the panel. Finally, Qy represents each one the generalized coordinates of the problems. Okay, after some manipulation and using the orthogonalization property of the vibration modes of the beam, one has the first system. Finally, the second system describes the equations models of the rotation motion of the satellites and the flexible displacement of the panels, respectively, where the term nonian alpha y is defined as centripetal digitally, and the tau q is the pseudo piezoelectric actuators. Now, an exact analytical model of fuel slosing motion inside a moving container is extremely difficult, and reasonable adequate models have been obtained with experimental results under the assumption as follows. First, small dispersion as velocity. Second, a rigid tank. Third, no viscous liquid and incompressible fluid. For the last characteristics, this can be found the following three equations, where the fuel tank is under action of the force F. The fixed mass is assumed to be non-slosing and stationary, which is located in the center of mass of the entire system, and affects the total mass of the inertia of the satellite. The moment of inertia above the center mass is zero, and M represents the moving slosing part of the fluid, which can accelerate the component of the direction opposite of the force. M0 as a consequence of the applied force. Finally, the model dynamics equation of motion about the center mass can be written as the first equations. The second equations represent the result of non-linear acceleration of the mass. When the simplified mathematical model of slosing mode is described in the third equations. Okay, so in conclusion, the attitude flexible satellite mathematical models with their main disturbances has been given in this representation. Now, for more considered disturbances affected in the geostationary satellites, the fuel cooptation can be considered in the future works in order to implement in the appropriate controller. Okay, that is all. Thank you for your attention.